In a new computer game, each time a player performs an action, there is a random chance that the action will be boosted. In the first model, the probability that the action will be boosted is constant. A. Suppose the probability that an action will be boosted is 0.1. Find the probability that the first boost occurs on the third action. So the first on the third action, what does it mean? There must be what? No boost on the first trial and no boost on the second action, and boost on the third. No boost, it's like not event, it's what 1 minus 0, 1, it's 0.9. It's and, so it's multiplication, 0.9, it's also on the second trial, and 0.1 on the third trial or on the third action. And you need just calculate it, and it's 0.081. The next, find the probability that at least one boost occurs in the first 6 actions. At least one. What does it mean? 1, 2, 3, or so on up to 6. And for such type of questions, it's more useful and more easier to calculate as 1. It's a total probability minus the probability of no boost in the first 6 actions. And since there are no permutations, all events are the same, and each event it's no boost. It just to the power of 6, no boost, it's what 0.9 to the power of 6, and it is equal to 0.4692, 3 significant figures. And definitely it's a binomial distribution, and also can be calculated as binomial, but when there are no permutations, all events are the same, it's just to some power. But if if you want to use binomial, let x be number of boosts in the first 6 actions, and x is distributed binomially, n is 6, and probability to be boosted is 0.1, and you need what? At least one. So you need probability x is greater or equal than 1. It can be calculated directly, or it's 1 minus probability that x is less or equal than 0, or just probability less or equal than 0. You may use binomial CDF with 0, or it's there is only one event, it's just minus probability that x is 0, and x is 0, it's binomial PDF for x is 0 with given parameters. The next, suppose the probability that an action will be boosted is p. Explain why the probability that the first boost occurs on the x action is p multiplied by 1 minus p to the power x minus 1. So it becomes what? The x action is boosted, and it's very important, and since the first event occurs on the x trial in general, so it means that the x action is boosted, and all previous actions are not boosted, and the corresponding probability becomes what? 1 minus p. It's n, so it's multiplication multiplied by 1 minus p and multiplied by 1 minus p, and x minus 1 times and multiplied by p, its probability to be boosted at x trial or action, and you can see that it becomes as required 1 minus p to the power of x minus 1 and multiplied by p as required. The next, let x be the number of actions until the first boost occurs. Hence, write down an expression using sigma notation for e of x, its expected value or mean of x in terms of x and p. Just using the formula, you remember that what e of x, it's the sum for all possible values of x, and x multiplied by the corresponding probability, but it can be at absolutely any trial, so x may be absolutely any integer up to infinity. So the first boost may be absolutely at any trial, at any number of action, so it becomes the sum for x is 1 up to infinity x multiplied by the corresponding probability, but the corresponding probability is this value. It's you can see that it's clear that probability that the first boost occurs on the x action is this value. So x multiplied by p, 1 minus p, x minus 1. The next, consider the sum of the infinite geometric sequence. By differentiated both sides with respect to r, find the expression for the sum for n from 1 to infinity, and n multiplied by a multiplied by r to the power of n minus 1 in terms of a and r. And definitely all questions are related, and if, for example, if you don't know what to write for this question, it may be a hint for you. So since it is given that we should differentiate, let's differentiate both sides. So, and we differentiate with respect to r, so it becomes a, it's constant, so derivative is 0, plus ar, derivative it's what? It's just a, plus this derivative is 2ar, plus the next term is ar cubed, so it's what? 3ar squared, and plus so on up to infinity, and it is equal to what? Derivative of this, and a, it's a constant, and 1 minus r, it's to the power of negative 1, and we should apply what? Chain rule, something to a power. We use the same rule as for x to the power of n, so it becomes negative 1 1 minus r to the power of negative 2, which is squared in the denominator, and this derivative 1 minus r derivative is just negative 1, so negative 1 arises, minus minus it's plus, so it becomes a over 1 minus r squared. And let's consider what is this, what is it. Let's write a few terms. So sum for n from 1 to infinity, n r n r to the power n minus 1. Notice that we should substitute for n changes, so it becomes, when n is 1, it becomes what? 1 or a r to the power of 0 plus what? When n is 2, it's 2a r and plus so on. So you can see that it coincides with this. So absolutely the same. So we can conclude that it is equal to what? A 1 minus r squared. The next hence shows that E of x is 1 over p. What is E of x? E of x is this sum, and definitely we should use this result to find this value. And let's compare, or let's rewrite. We need E of x, this sum for x from 1 to infinity, x p 1 minus p to the power of what? X minus 1. And you can see that this sum coincides with this sum when what? You can see that summation is with respect to what? Xn. So you can see when n is x and a is p and 1 minus p, or when r is 1 minus p, you can see that they coincide. So we can say that it is equal to what? This, but a is p and 1 minus, and r is 1 minus p squared. And you can see that it's what? P over p squared, and it's 1 over p as required. The next, it can be shown that variance of x is 1 minus p over p squared. Find E of x and variance of x when p is 0.1. You need just calculate substituting 0.1 for p. So E of x is 1 over p, so it's 1 over 0.1, it's 10. And variance of x becomes what? 1 minus 0.1 divided by 0.1 squared. It's 0, you may use just a calculator, 0.9 divided by 0.001, and it's just 90. It's just 90. The next, in the second model, the initial probability that an action will be boosted is 0.2, and each time an action occurs that is not boosted, the probability that the next action is boosted increases by 0.2. After an action has been boosted, the probability resets 0.2 for the next action. Shows that the probability that the first boost occurs on the third action is 0.288. So what does it mean? So the probability that the first boost occurs on the first trial or the first action is what? Is 0.2. And if no boost on the first trial, probability that it occurs on the second trial, it's plus 0.2, it's 0.4. And provided that no boost on the first and no boost on the second, probability that it occurs on the third, it's what? 0.6. And it's very important to emphasize that no boost on all previous trials, and so on. Probability that it occurs on the fourth trial is 0.8, provided that no boost on all the previous. And you can see that probability on the fifth trial is it's 1, And what is 1? It's a certainty, provided no boost on the first 4 trials. And what is the question? So shows that the probability that the first boost occurs on the third action. On the third action, it means that no boost on the first, and probability that it occurs on the first is 0.2. So probability of not event is 1 minus 0.2 multiplied by, because it's and it's at the same time, on the second trial also no boost, but probability to be boosted on the second trial it's 0.4, so not event it's 1 minus 0.4, and multiplied by to be boosted on the third it's 0.6, and it is equal to 0.288 as required. Let y be the number of actions until the first boost occurs. Explain why y is less or equal than 5. 1 mark. It's actually about this. So you should answer, or you may say the next, that after 4 actions that are not boosted, the probability that the next action, it's actually the 5th action, is boosted is 1, and 1 is a certainty. The next, the following table shows the probability distribution of y. Find the value of m and the value of n. So what does this m mean? It means that the first boost occurs on the second trial, and m is what? Not event on the first trial, it's what, 0.8, or 1 minus 0.2 to be more clear, and event on the second trial, or will be boosted on the second trial, and probability is 0.4. 0.4, and it's 0.32. And since there is only one unknown parameter, it will be much easier to find it as what? 1, its total probability, minus the sum of all other probabilities. So n can be found as 1 minus 0.2 minus 0.32 minus 0.288 and minus 0.0384, and it is equal to 0.1536. Shows that expected value of y, or mean of y, is this value. Expected value, just apply formula. It is given in a data booklet, and it's what? It's the sum over all possible values of y, and y multiplied by the corresponding probability. So it becomes just 1 multiplied by 0.2 plus 2 multiplied by 0.32, formula is given in a data booklet, plus 3 multiplied by 0.3 288 multiplied by 4 times n, what is n, 0.1536, and plus 5 multiplied by 0.0384, and it is equal to 2.5104, or you may round to 3 significant figures. Find variance, and we know formula is given in a data booklet that variance can be found as expected value of x squared minus mean or expected value of x squared. So variance becomes expected value of x squared. It's similarly to e of y, but you should substitute x squared instead of just x, so it becomes 1 squared, and again times corresponding probability plus 2 squared, 0.32, plus 3 squared times 0.288 plus 4 squared times 0.1536 plus 5 squared times 0.0384. It's expected value of x squared, and minus this squared, expected value of x squared, and it's 1.19 to 3 significant figures. The next, use the expression given in CII to find the value of p for which e of x is equal to e of y. E of x, it's 1 over p. It's somewhere here. Is this 1 over p, and we need just find the value u of p, and you can see that there is only one mark, so it must be very easy. So e of x, it's what? 1 over p, 1 over p, and it should be equal to e of y. E of y, it's 2.5104, and just calculate p, which is 1 over this value, and it's 0.398 to 3 significant figures. The next, find variance of x for the value of p. It means for this value of p, and you remember this formula. It is given variance of x is 1 minus p over p squared. So variance of x is 1 minus p over p squared, and substituting this value for p, it becomes 1 minus 0.398 divided by 0.398 squared, and it is equal to 3.80 to 3 significant figures, and it's 3.79 if you use exact values. We use rounded to 3 significant figures, so we get this result. And the last question, you can see also only 1 mark. Hence determine with a reason which model provides a more consistent experience for the player with respect to boosted actions. And actually, what does it mean to be more consistent? It's about what? It's about that variance or standard deviation, because variance is just standard deviation squared. Describe variance or standard deviation describe what? The spread of data, how far points or values are relative to each other, or how far they are relative to the mean, and the closer to each other or the closer to mean all data is, all points are, and it means what? The less variance is, or the less standard deviation is, and so that we say that such data is more consistent. It's more closer to each other, or more closer to mean. So the less variance is, or the less standard deviation is, the more data is more consistent. And since we know variance for x and variance for y, and actually it is given hence, so we need just compare variances, and we can see that variance of x is 3.80, and what is variance for y, or y, it's 1.19. so variance, and it's actually a reason, so variance, or since variance of y is less than variance of x, second model, second it's where y, model provides more consistent experience. And that's all for this question.